Hello everybody, this is Miss Lindsay. Today we're going to do the second example from our second day of related rates. So let's go ahead and jump into it. A ladder is 10 meters long. Its top is slipping down along a vertical wall while its base is being pulled away from the base of the wall at a speed of 0.25 meters per second. Let's go ahead and draw this. So I have a ladder leaning against a vertical wall. I didn't draw that very well, but that's supposed to be a vertical wall. And then, so here's the floor. Here's my ladder. That is at a constant. My ladder's not changing. It's 10 meters. Its top is sliding down. So again, this is sliding down the vertical wall while its base is being pulled away. Again, that's going away from the wall as the ladder's falling down the wall or slipping down it. Okay, so again, its top is sliding down along a vertical wall while its base is being pulled away from the base of the wall at a speed of 0.25 meters per second. Well, let me go ahead and just label these. I'm going to call this H and B. So again, we assume the wall and the floor are a right angle. So hopefully you're looking at this and thinking Pythagorean theorem. A squared plus B squared equals C squared. Okay. But we have a few other things here. We've got a speed of 0.25. I'll go ahead and write this over here. 0.25 meters per second. Well, what is that exactly? Well, that is when the top is slipping down along a vertical wall while its base is being pulled away. So that's when the base is being pulled away. So that's dB dt. Because again, this is when it's being pulled away. We want to know how fast, so again, our rate is the top of the ladder slipping down when it is 6 meters above the base of the wall. So this is later information. Later. So again, at some point in time when the height of that ladder has gone down 6 meters. Before we can substitute anything in, we need to take the derivative with respect to time. So let's go ahead and do that. Should be h dt. And then when we take the derivative of 10 squared, this is simply just an integer, a number. So that's a constant, that would be 0. And now we can plug a few different things in. We know our height is 6. We know dBt is 0.25. So I have 2. And then I have h is 6. And then I know, again, dB dt is 0.25. And this is going to be equal to 0. And now I have a couple other things to address. dH dt, well, that's how fast the ladder is slipping down, so that's actually our rate that we're trying to solve for. Well, what is B? Well, hopefully you realize when we now take this later time here, which is 6, we can find out what B is at a later point in time by using Pythagorean theorem. And hopefully you recall from geometry, this is simply a triple, 3, 4, 5 triple. If not, go ahead and work through the Pythagorean theorem to find your B value of 8. Okay. And then let's go ahead and figure this out. So if I plug this into my calculator here, I'm going to get that to be 4. And then 2 times 6 is 12. And then again, you just continue to solve. So 12 dH dt equals -4. And then divide by your 12. So that's going to be -1/3. And again, this is measured, I believe, yes, in meters per second. Okay. And that concludes example number 2.